On to the next. Alright, for these we're drawing a solid line for the motion of the black object and a dotted line for the motion of the white object. We've got a white ball that is dropped from rest. So that means we have an initial velocity of what? That's right, 0 at the top of a building. At the same time, a black ball is thrown upward with an initial speed of 30 meters per second. Use g equals 10 meters per second squared, and we'll let up be positive as usual. Let's start off with a white ball. It's dropped from rest on a building, so we know the ball is going to just go like this, right? And it's going to accelerate as it gets farther and farther down. So acceleration in this instance, our speed starts at 0, and if down is negative, then our velocities are getting more and more negative. So what kind of acceleration are we going to have? Negative acceleration. We're starting from an initial velocity of 0. So we're going to start here, and then it'll be a straight line down. And what should the slope of a velocity versus time graph be? The acceleration. And in this case, our acceleration should equal g, which equals negative 10 meters per second squared. So you would start with a point here with the initial velocity, which is our y-intercept for this one. Our initial velocity is 0, and then we have a negative slope of 10. 1, 2, 3, 4, 5. Each of these vertical lines are 1 second. 1, 2, 3, 4, 5. Each of these horizontal lines are 10. So it should, let's use a line instead of the dots. There you go. Never mind. It erased. Outstanding. That's great. Here's my line tool. Sorry for the delay. There we go. That, if we calculate the slope, is going to be that negative 10 meters per second squared. Onto the black ball. We'll use a different color here because the dotted lines for me are not going to be easily shown. You can use different colors. That's fine. We're going to start with an initial speed of 30 this time. So 1, 2, 3. So there is 30. What is our acceleration? So it goes up and then back down. What's our acceleration the entire time? That's right. Our acceleration is just that negative 10 meters per second squared. So we're going to go negative 10. Now, we are changing velocities, we're changing directions at the top because we're slowing, going against gravity until we reach a velocity of 0, and then we start speeding up in the opposite direction. So that means we're going to be moving with a constant acceleration, these dots, and then right about here, we're going to be changing directions. Remember, whenever you cross that horizontal axis on a velocity versus time graph, that indicates that you have changed directions. Now these two lines on the graph should be exactly parallel to each other because they are the same exact slope. It's negative 10, so the two lines would never cross, even though it looks like maybe they do. That's just me being rushed. Onto the white car, goes forward with a constant speed of 20 meters per second. At time t equals 0, a black car begins to accelerate from rest with an acceleration of 5 meters per second. I want to do the black car first because at t equals 0, it's accelerating from rest. So that means my 0 is here. And what should my slope be? Well, if my acceleration is 5 meters per second squared, and this is a velocity versus time graph, then that means my slope should be 5 meters per second squared. So let's see what we're dealing with the graph. We've got 1, 2, 3, 4, 5. So it looks like each of the vertical lines is 1. 1, 2, 3, 4, 5. Each of the horizontal lines are 10. You can go ahead and fill these in as a reminder. That would be 40, 30, 20, but as you can see, it's going to be just a big sloppy mess if I do it. So I won't, but you can. So now looking for this slope of 5, finally, we're going to go up 5, which if each horizontal line is 10, that means we're going to go into this little smaller, lighter line. So that's up 5 over 1. And you can just do this to get your nice straight line. I can cheat because I have the line tool, and that's what our graph will look like for the black car. For the white car, let's go to yellow. All right, so we're starting with a constant speed of 20 meters per second. 10, 20. Constant speed of 20 meters per second. And there we are. There's your two graphs. Now what you can do with this graph, you can go and figure out the displacement. You can see that these two, something happens right here. What is it that happens? Neither of them are changing directions. You can figure out the area under the curve. So you can figure out your displacement for this one. And then you can figure out your displacement for this one. And you can see where they will meet or crash, depending on that. So lots of cool stuff from these graphs. I'll be back with the next one.